slopes of parallel and perpendicular lines. So remember, parallel lines are two lines that never intersect, and on a coordinate plane they're going to have the same slope. Okay. One thing to note about parallel lines or lines with the same slope is you can have two lines with the same slope that are not parallel because they are the same line. Okay, we'll look at that a little bit later, but it's one thing to keep track of. All right, perpendicular lines, two lines that intersect to form a 90-degree angle. And on a coordinate plane or in an equation, perpendicular lines have inverse reciprocal slopes. Okay, that means that if the slope of my first line is, I'll say 2/3, the slope of my second line is going to be negative, okay, inverse, and then the reciprocal, or 3/2. Okay, same thing if my first one is an integer, -3, my perpendicular line, or my perpendicular slope, is going to be a positive 1/3. Okay, I can drop the 1 in there so it's easier to see. Okay, so inverse reciprocal slopes. All right, we're going to use this to figure out parallel lines and identify them. The fact that they have the same slope is something that's going to make this much faster to see than if we had to graph each one and say, oh yeah, they look like they are not going to touch, right? They look like they're staying the same distance apart from each other. So we can go through quickly and we can identify which lines have the same slope. So we're looking at slope-intercept form, y equals mx plus b, or point slope form, y minus y1 equals mx minus x1, and we're going to be looking for the slope in both of these equations. Okay, so I can quickly see that this has a slope of 2, this has a slope of 1/2. That means they are not parallel. It also means they're not perpendicular because both of these are positive. Okay. This next line, this has a slope of 2. This has no slope, right, or a slope of 0. Let's write that. Okay. And then down here we have another line with a slope of 1/2. So we know which lines could be parallel. All right. To really tell whether they're parallel or whether they're the same line, we have to make sure that their y-intercepts are different. Okay. Or that they run through a different x value. Okay. That's another way of, or a different y value at any x value. That's a different way of doing it, but you can also do it that way. So the first way is just to put both of these equations in the same form. Okay, so I'd have 2x, and 2 times -5 is going to be -10. So I would have y equals, y minus 2 equals 2x minus 10. I'd add 2 to both sides, add 2, and I'd have y equals 2x minus 8. Okay, now that I got them in the same form, I can easily tell that these y-intercepts are different, so these two lines are parallel. Slopes are the same, y-intercepts are different. All right. The other way I could do this is I've got my y-intercept here, right, and that's where x equals 0. So what I can do is I can just plug in 0 for this one to see if my y is a different value. Okay, so if I have this is 0, 1/2 times 0 is 0, 1/2 times 2/3 gets complicated, but we can do that. Oh, I guess it's not too bad. Maybe I made that one easy on purpose. So 1/2 times 2/3. Those cancel. We're left with 1/3. 1/3 is not the same as -5, so these two have the same slope, different y-intercepts, so they are parallel. Okay? Sometimes we'll get equations that are not in either of these forms, and really what we have to do is we just have to convert them to slope-intercept or point-slope form in order to look at their slope. Okay? And we can do that real quick. Divide by 6, divide by 6, divide by 6. We're going to have 2x equals y minus 3, and move my 3 over, plus 3. I would have y equals 2x plus 3. Y equals 2x plus 3 is the same line as my line up here, which means these are not parallel, these are the same line. But this line, this equation, right, is parallel to this line because these two have different slope, different y-intercepts. Okay, same thing down here. Divide by 2, divide by 2, divide by 2. I would have y, going to add x over 2 to both sides, so I'd have y equals x over 2, or 1/2 x, plus 4. And I can see that's got a different slope than either of these lines that have a different y-intercept than either of these lines that have 1/2 as their slope. So that's also parallel to those two lines. And then this last one does not have an x value, doesn't have an x variable, so it doesn't have a slope. So its slope is going to equal 0. But I do need to figure out if it's going to be the same line or a parallel line. So let's combine these first. 13 minus 16, -3, divide by 3, divide by 3. I get y is equal to -3 over 3, or -1. And my slope is the same, but my y-intercept, -1, is not the same as 2. So these two lines are parallel.